Good evening everyone, myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss about the dual nature of the radiation and a matter. This is the part 1 video and I will discuss one by one in each and every steps. Okay. So first of all we need to understand what is an electron emissions. Okay. In a metal, an electron is an outer shell of the valence electron and loosely bound to the atom, and hence they are free to move easily within the metal surface and body can live with. Such an electron is called an free electron. Let us consider this is the outermost orbit, and inside this there is a neutron as well as proton, and after that there is an electron, and second most orbit there is a electron. So this is the outermost electron, right? And it is free, loosely packed, or it is held loosely held. So if possible, if you will apply a small amount of force, a small force, so what will happen, this electron will try to move, right? And this is known as free electron. And this basically in every metal you will find a free electron, right? This free electron can be emitted from metal if they have a sufficient energy to overcome the attractive pull. So these have some attractive pull, right? Attractive pull. And if we will apply an external force, so what will happen, this electron will gain energy and overcome this, and this will come out. So this method is known as electron emission, right? Now there are several types of electron emission. So first emission is your thermionic emission. Thermionic means what? Thermionic means heat. Thermal means heat, right? Heat. Therm means heat, right? So there is a sufficient thermal energy can be imparted to the free electron of a suitable heating. Let us consider there is a metallic plate and it has an electron, and if it will get 100 joule of energy, then what will happen, electron will come out or jump out. So if you apply a heat energy to this metal, and it must be greater than 100 joule, then what will happen, electron will gain energy. Electron will gain energy. And if electron will gain energy, then electron will come out and it will start moving. Electron will start moving, right? Start moving. Got it? And this method is known as thermionic emission. Now next one is your field emission or cold cathode emission. What is field emission and cold cathode emission? Let us try to understand. If you draw the cathode as well as anode, so let us consider this is a vacuum like structure. So what will happen, there is an electron, and if you apply a potential difference between these two, so what will happen, this is a positive charge and this is a negative, and this is a negative, right? And this is positive. So what will happen, if you apply a voltage, very high voltage, so what will happen, there will be a and there will be a very high positive charge, very high positive charge, right? So due to which what will happen, it will try to attack, it will try to pull the electron, right? So as soon as it will try to pull the electron, so electron will come out from this plate and it will start moving. And this is considered as an field emission or cold cathode emission. It is the phenomena of emission of electron on the surface by metal by applying very strong electric field. So basically what will happen, electric field is being applied. So electric field is being applied, and due to which what will happen, electron will start moving, right? And the voltage should be at least approximately very strong as 10 to the power 8 volt per meter to a metal. And one of the example of cold emission is spark plug right? Now I hope you have understood this. Spark plug. So spark plug means, I hope, see here, actually what happens, when you have you ever seen in the bike or bike engine, you will find a spark plug like this. Okay, so what will happen when you apply a strong electric field? So what will happen? The electron will come out from this and a spark will be produced, and this spark is used for burning or combustion of the engine. So that's why electric spark has been produced every time by the help of electric field in the bike engine. So I hope you have understood this. Now let us go for this one, photoelectric emission. So what is photoelectric emission? Photo means what? Photo means light, right? So light, with the help of light, it is this emission is being done. It is a phenomena of the emission of the electron from the surface of metal when a light reaction of a suitable frequency fall on it, and hence energy of to the free electron for their emission is being supplied to the light photon, and the emitted electron are called as photoelectron. So let us consider there is a photoelectric plate and it has been connected to the. So what happens? This is the method to check. See what happened. It has been observed that when you put some rays of the light of the desired frequency, so what will happen? It will try to emit an electron from this in this direction, and when this electron will move, so what will happen? There it will complete the circuit. It will complete the circuit. Complete the circuit, right? And when it will complete the circuit, so what will happen? Current will start flowing. Current will start flowing. Current will start flowing, right? It means that whenever you apply a light energy, so what will happen? It will try to pull the electron, right? And this type of emission is considered as a photoelectric emission. This type of emission is considered as a photoelectric emission. And the electron emitted in this phenomena is called photoelectron. Photo means, always remember, light, right? And the number of photoelectron emitted depends on the intensity of the incident light. If you increase the intensity of the incident light, so a number of electron will increase and hence current will also increase, right? So I hope you have understood this. Now there is a method known as secondary emission, and it is the phenomena of a emission of electron from the surface of the metal, and in the large number fast moving electron called primary electrons or other particles strike the metal. So let us consider this is the metallic surface, right? And there is an electron which is moving very fast, right? Very fast. So its kinetic energy will strike and it will disturb the electron, and after this what will happen? Electron which is inside electron which is on the metallic plate, so it will gain this kinetic energy. See, this electron will lose kinetic energy. This electron will lose kinetic energy, and this electron will gain the kinetic energy, and after gaining, what will happen? After gaining kinetic energy, what will happen? It will try to move out of the, it will leave the metallic surface, and as soon as it will leave the metallic surface, so what will happen? This phenomena, this emission is known as emission of electron is called as secondary emission. So I hope you have understood this, right? Now, the more important terms, it is known as work function. What is work function? A certain minimum amount of energy required to be given to the electron to pull out the surface of the metal. This minimum energy is known as the minimum energy required to electron to escape from the metallic surface is called the work function. Let us consider there is a sodium or any metallic surface is there, okay, and it has work function. Let us consider this as a work function of 100 joule. or before work function we don't know the work function, so let us remove this, and you try to apply energy. So any type of energy for the emission of electron, you can apply any type of energy. So if you have applied an electron energy, let us consider you have applied energy of 10 joule, and you have seen that no emission take place. Again you have increased from 10 joule to 20 joule, still no emission take place. Again you have increased from 20 joule to 30 joule, so it's still no emission. After that you have again given the frequency of energy of 50 joule. So what if it has been observed that the electron starts moving out. Electron starts moving out. But as soon as you will go for a 49 joule, so no electron emission. But as soon as you go for a 50 joule, so electron start emission. So the minimum amount of energy required to emit the electron from the surface is known as the work function. So if you want to define it, so work function is the work function. It is the minimum, it is the minimum amount of energy, minimum amount of energy required to pull electron from particular metallic surface is called its work function. Its work function. Here phi naught, if you will, work is a work function, it denotes the work function. So we can say that 50 joule is the work function of this metallic surface. So different metallic surface will have a different work function, right? And this work function has been measured. See, work function of the metal, it is generally denoted by phi naught or W naught and measured by electron volt. Electron volt is the unit of a joule, a unit of energy only, and it depends upon the property of the metal and nature of its surface. It decreases with the increase in the temperature. As soon as temperature will increase, so minimum energy required to pull. See, let us suppose now it is a colder time, so you require 50 joule. But if the temperature of the room will increase, so what will happen? So what will happen? Its temperature will basically increase for 10 degree or 10 joules. So what will happen? Heat amount of, see here, if amount of heat already given by the outer temperature, so its work function will be less. Let us consider 10 joule, 40 joule only. Why? Because already it has gained 10 joule of energy from the room temperature, and after that you required only 40 joule. So as soon as you will increase the temperature of the room, so what will happen? It will decrease the value of work function. One more important thing is that the it has a unit of electron volt. So one electron volt will be equal to 1 into value of electron is how much? 1.6 into 10 to the power minus 19 coulomb, and in voltage is 1. So 1 electron volt can be considered as 1.6 into 10 to the power minus 19 joule. So this is the very important value. So you need to remember this value. So I hope you have understood this work function. Now I will discuss. So I hope you have understood this. Thank you for watching my video.